So matter is anything that has mass and takes up space,
Okay.
right?
Anything that has mass and takes up space.
Hmm.
All right.
And so we're going to do a quick card sort activity where students are going to negotiate. I think that's what you would use, negotiate.
Yep.
What items can be classified as matter and what items cannot be classified as matter.
Yeah. And as you pull up your screen share, one of the things is when we say negotiate, justify and reasoning are important higher level skills that students need to get to. And so this is part of learning justification and reasoning. That's why we do claims and evidence. Anything you claim, you have to have evidence to support that reasoning. And so this is a really good conversation, I think, for students to help them push them into a higher level of understanding through that negotiation. All right. So
Okay.
what do we have here? What is a card sort activity?
All right. So we just said matter is anything that has mass and takes up space. And we want the students, before we start getting into states of matter and beyond, we want students to have a little bit of time to discuss in small groups what sorts of things are matter and what sorts of things are not matter. And so I just made this on Google Drawings, and kids are going to be able to log in. You could actually have several kids together working on this at the same time because it is a Google Drawing. And they're going to just click on each of these tiles on the sides and drag them into either, yes, this is matter, or no, it's not matter. So if we're here with heat, you say, well, heat, I can feel heat, but I can't really put heat on a scale and take its mass. So I'm going to say heat, I'm thinking right now it's not matter. And then let's say I change my mind later and, oh, maybe I think heat is matter. And then I can scoot it over from here. But I'm going to leave heat right now in the not matter category. And then
Okay.
you can go. And the nice thing is, if kids are doing this collaboratively, if they're all on the same Google Drawing together, they can all, if you could have three kids moving three different tiles at the same time and working back and forth. One, we have, okay, water. Well, I know I can get the mass of water, and I know water takes up space. And so I'm going to go ahead and put water in the yes, this is matter category.
And so doing this, you made this card sort in the Google
Google,
Draw.
Google Drawings. Mm-hmm.
Okay, Google Drawings.
Mm-hmm.
And is this something that you can like share and we can copy into our drive?
Yes, in fact, it's
Okay.
included with the lesson that we're providing.
Okay, perfect.
A link to it. How about the color yellow? So it's a color. Our colors matter?
No,
No? Yeah.
no,
So if yellow is not matter, blue probably is not
no.
matter. But what about air? Air,
Yes, because I can blow up a balloon.
okay, there we go. We know. How about electricity?
Ooh, that's a tough one.
It's a good one.
Oh,
I'm going to go ahead and put electricity in the not matter.
no,
Light.
it's energy,
Yeah.
not matter.
Energy. That's a good point. Yeah, it's energy, but we can't get the mass of electricity.
No.
Light is another one there. Some of these are kind of abstract for them to think through.
Hmm.
Sound in there with light. But then I think,
Hopefully, they've talked about waves and electromagnetic spectrum.
mhm.
Hopefully, they've had that lesson so that they know when we say that is a form of energy, what these things, when we say light, oh, that's a form of energy. Sound is electromagnetic spectrum, it's energy.
Right. And so there we go. And then this is created, like we said, in a Google Drawings. You could have kids working on this together collaboratively or on their own. And then this can be shared back with teachers too. So you can then get that feedback from the students and then also probably share feedback with the students on this. So it can all
Now,
be done
when
virtually.
you share something like this with students, just a little bit of how the heck this works at the moment.
Yeah.
Do you share it like as a copy only? Then they have to copy it, do
When
the
you go
score,
into
and then share with you?
When you go into Google Classroom and you can actually post this as a link in as an assignment in Google Classroom, and when you post that as an assignment, you have the option for every to make a copy for every student. And then that just automatically every student then gets a copy of it. If
Okay.
you want students to be able to work collaboratively with it, then they have to be able to all be shared on the same copy. So let's say if we wanted, Stephen and Sarah and Susan and John to all be, shared on this, we would all have to be right up here on the shared settings. And then we'd all have to be listed here that we were all editors for this document to be able to collaborate together.
So it sounds like if you have Google, if you're a Google school, it sounds like it's easiest just to put it in the classroom, then they can all download their own, they can work together, but have to turn in their own sheet.
Yeah.
It'd be easiest probably.
Mm-hmm.
Less work for me.
Yeah.
I'm all about that.
So
we just did the
card sort activity.
Right? Okay,
Yeah,
we've just done a card sort.
And so we know that everything is matter. Matter makes up everything.
Everything that has
mass and can take up space.
Mass and space is matter. Okay, because we discussed the color yellow is not.
That's correct. Yeah, the color yellow is not matter, right? And electricity is not matter. It's energy, but it's not matter.
Okay.
So matter can be categorized as pure substances and mixtures. And there are two kinds of pure substances. We have elements, and those are the simplest form of matter that can exist under normal laboratory conditions. So we can't break elements down into any simpler substances. And there's a list of all the elements on the periodic table. And then we have compounds. And compounds are made up of a couple of different elements in a known ratio. But compounds can be separated through a chemical change. So, for example, water can be separated if we can set up a battery to do electrolysis. We could separate water into hydrogen and oxygen. And carbon dioxide, we know carbon dioxide is carbon or CO2. And so plants undergo photosynthesis to change carbon dioxide chemically into carbon and oxygen gas that we can breathe. But then you can also classify matter as mixtures. And mixtures can be separated into simpler substances through a physical change. And so one example of a mixture is air. Now, we're not going to separate air today, but I wanted to show something we can do with air. Air is a gas. Mm-hmm. And this, we're kind of going to lead into states of matter, and we know gases can be tricky to work with anyway, and then with really sophisticated instruments. And so in the middle school classroom, how do you work with gases? Well, one way that's pretty good that students can easily use is to get a small syringe. And so that's what we have right here. We have a 10 mil syringe with a lower lock tip, and what we're going to do is we're going to fill some air in the syringe. So we're going to pull the plunger out just a little bit. And then we have these caps.
You said a little bit, but you went all the way out.
I went to like
10.
9. Okay. I'll put it at 7. And we're going to take this cap and we're going to cap it on, once there's some air in the syringe, we're going to cap that syringe. And so now we've created a closed system, and we can kind of start to get a feel for the particles that make up a gas by playing with the pressure and the volume of a gas. So once you have this cap on and you know that the air is in here, what you're going to ask the students to do is to depress that. Now, we don't want the students like ruining the syringes. So we know they're very strong and they could absolutely defeat the cap, but just press that in a little bit, and they should feel that resistance. They should feel that as they press that syringe in farther, that the pressure is increasing, and that the volume of that is also going down. So we know pressure is going up, volume is going down. So imagine what is happening to the particles, the air particles that are trapped inside here. And so if the students are using a scientific notebook or a science journal or something, they could think about what those particles would be doing before they press it in. So where would those air particles be? And then after they press it in, what would be happening to those air particles? And hopefully they're going to represent that the air particles are getting closer together as the pressure is going up and the volume is going down, and it's feeling tougher to push it in. All right.
Okay.
So that's just a simple demonstration there. So that is
all right. So this is a demonstration to think about the particles.
The particles
distance
making up
between
a gas.
the particles.
Distance between the particles making up a gas. Yes.
Okay. Does that have anything to do with the compound mixture thing that you're talking about?
Yeah. So just the air is an example of a mixture. So I kind of talked about how we have elements on the periodic table, we have compounds, and you can only separate those by chemical changes. And then air is an example of a mixture. We can't separate it with a syringe, but we can get a feel for the distance between the particles with that, even though we can't see them.
Okay.
Okay.
Okay. All right, that makes sense.
Okay.
I'll give you that.
This is a really neat web page that I ran across the other day. It's ptable.com. And there's a couple of different tabs. I love every tab on here. So there's properties, and you can look at all kinds of things. Can get pretty beyond middle school. So, they have the electron configurations and images, orbital diagrams and different things, isotopes, compounds. But what I really liked on this for the middle school workshop was this very first one. I know it's a Wikipedia tab, but it's the periodic table, and it has this temperature slider right here. And so we know elements are a pure substance. And as far as matter goes, matter can be three different types of substance. It can be a pure substance, which is either an element or a compound, or it could be a mixture. So for this is kind of showing elements. And if you select this temperature, so all I did is I left clicked on the slider bar. And what I'm seeing right now in the center, it's showing me the temperature right now. So it has it clear down to absolute 0, which is 0 Kelvin. That's true cold, right? And so negative 273, negative 4 Fahrenheit. But then the other thing that you'll notice are that all of the boxes except helium right now are all in solid state. And so this is at 0 Kelvin. So at this temperature, all the particles that make up these, like the element itself, right? That particle is not moving. It's completely, there is no energy happening right now. But then as you give it some energy, so as I am selected down and I'm moving up, now I see my temperature is increasing, and I'm going to start seeing the states are going to start changing as my temperature goes up. So there's 7 degrees Celsius, 280 Kelvin. And now I can see that all of my noble gases are gases now, and fluorine and chlorine and oxygen and nitrogen and hydrogen. But then I see a couple of liquids as well. Bromine and mercury at 7 degrees Celsius now are liquids. And then I can continue going up. And it's going to let you, this is just such a neat visual for the students to see as you keep adding. Now we're at 908 degrees Celsius. That's really, we would never be able to simulate this sort of this temperature, definitely not in the classroom. This is very, very hot. You can keep going, and it's gonna
not on Earth.
You're right. It's gonna keep going, but I like it goes all the way until all of the elements that you can see on the periodic table, it turns them all into gas. And that stop point, and except the ones that we don't know. So elements that don't have stable isotopes are going to be left in gray because we don't know for sure what those states would be. But at 6,000 Kelvin, now we've seen, now could it get hotter? Of course, it could keep going. But at this point, they're all gases. And then beyond gases, then we would get to that plasma state. And we can't replicate plasma on Earth. So it's just going to keep solid, liquid, and gas for us. So I just think this is just a neat resource to show students, to have them kind of play with and think about some questions. But I like that it gives it that visual change in state as temperature increases.
So where's gold? Where's gold on there?
Gold is right here, 79.
Yes. Oh, there it is. So where does it become a liquid?
It becomes a liquid. Got excited because mercury turned into a liquid. Looks like right about some materials. We want to think, what material would help ice melt the quickest? And so if we have some cubes of ice, and some materials we have here, we have a piece of styrofoam, we have a piece of wood, we have very small pie plate, we have a larger pie plate. And so we're going to just put, we also have the plastic lid of our tub. And what we're going to do is we are going to place a different ice cube on each of these materials.
They've just been sitting in the lab.
Yep. And we're just going to see.
They're all the same temperature.
This is all happening at the same time. They're all about the same type of ice, or type size of ice. Of course, they're all the same ice. And we're going to see, do any of these, which materials do the ice cubes melt the quickest on?
I'll take a picture for my lab journal. And I'll shut off my flash. That way I can put that in my lab journal. That's right.
I like that you're referencing the lab journal again. And this is where you can make predictions about which material might help the ice melt the quickest and why, and which material might insulate the ice the best and why.
And this is where I break out a fan. Obviously, this is something we're going to do like at the beginning of the period and
Let
look
it go.
at the end of the period where it is. If we have scales, we can even get the mass of it before and after to see, to get some data points.
This is just a nice experiment. If you're looking at phase changes anyways, this is just a great experiment to look at melting, right? And to have kids think a little bit, like you said, about materials that are good conductors and good insulators.
It's something easy to do. Like I said, it's something you have to set up right at the beginning. Have them make their plans. So plan the investigation, make the plans on one day. And why pick materials and why might this be, and have them make predictions and record all of that in their journal and design their experiment, what they're going to be, where exactly is it going to be, how's it going to be, how are we controlling variables as best we can. And so, I mean, if we put one of these up on top of a cabinet and one down on the floor, then obviously, well, it could be the height. We don't know it's the material. And so we talk about good investigations and good planning. Isolating variables is a good thing to talk about here. And like I said, if you're on 45-minute classes like most middle schools, then it's just something that you could very easily start. You plan it out, do all the planning, investigation planning. Then the next day, you know, as soon as they get in, they have to set it up and mark their time, record their time.
Right.
And then in like the last 10 minutes, they can go ahead and do the mass of it. And of course, they'd have to mass it as soon as they put it on, or before they put it on, and then mass it out, you know, after 30 minutes, 35 minutes or whatever class, to see which one has lost the most or melted the most.
Melted the most.
Melted the most. So you're going to say lost the most mass, but it's not lost, it's still there. It's just in a different phase.
Yeah.
And so, yeah. All right, so here's one I always like doing in the classroom that I thought was fun. And that is to do basically a water cycle in a baggie.
Okay.
And and again, if we're still doing remote in the fall, this is something kids probably have a baggie around and a Sharpie and some water. And so what we do, we just drew clouds, we drew water here, and then throw it on the floor.
Just threw one on the floor.
Put just a little bit of water in there. I like to put food coloring in it for a reason. And then tape this to the window. Now you can, you can have the kids label it if you want. You can have them label. And so you can put, you know, it's condensation, and you can
Probably
put evaporation.
Yep, condensation going down. So that'd be good.
But we'll put this in the window, tape it to a window, especially here this time of year, definitely work better even, because the sun shines through, then it will start evaporating, the water evaporate. And I like putting food coloring in it. Make sure I get all the food coloring washed down there. Because you see as I have that there now, it's blue. And you use any food coloring, it doesn't matter. I just grab blue because that's what we're getting ready to use for something else. And true. But if we get that down, it'll drop down. When it condensates and when we put this in the window and it condensates, what will happen is we'll have that clear water up here.
Oh, okay.
And so you talk about you're separating of a mixture and stuff, and we talk about what's, you know, the water is evaporating. And so we obviously won't be blue. Well, I can't say obvious because they won't know that. A lot of them won't realize that. And so, but this will be a bunch of clear condensation of water up here. Then they'll see the water running, the clear water running down into our reservoir.
I think you brought up a great point too, that with the phase changes, so the evaporation and the condensation, those are always going to be physical changes, and so that is another way that you can separate out a mixture. So that's a really, that's a great thing to bring out.
There we go.
Every phase change is a physical change.
Okay. I hadn't thought about that.
Yeah.
You high school teachers. So there's between high school and elementary. But this one, it's just an easy one to
like
do. You
that,
tape them up on the windows and you can see them. That's something you could assign them to do at home with them being, if we're remote part of the time or whatnot. That's something they can do at home and document it. They can write down in their journal what they're seeing. They can even take pictures and do pictures to document it, and have them use this as justification for the water cycle itself and what's happening in the atmosphere. Just a cute little modeling thing.
I like it.
It's simple, it's easy. Okay, that's playing. This looks pretty good. Okay, it's going.
Okay.
All right, so for convection currents, there's lots of ways of doing convection currents, aren't there? We have seen it done in so many different ways. We've seen these tubs propped up.
Yeah.
And I can't remember what they did for a heat source under when they propped it up. But I know we've seen it a lot of different ways. But basically, to get convection going,
Well, propped up before, you can put just a beaker of hot water and then a beaker of ice water underneath it, and then set the tub on top, and then just reach down in with a bottle of food coloring and just put a little drop, and just the heat and the cold underneath it will affect in the tank enough. So that's one way.
Sense. All right, you got a baggie of ice.
Yep.
Here's another way of doing it. We usually use a little bit thinner tubs, but this works still really well. Let's put some water in here. I probably shouldn't have done that yet, but I did. And then there's different ways. We have containers with weights on the bottom of it for our big demo that we do.
Yeah.
But one of the ways I've seen people do is just pour hot in and get that going.
So I'm just going to snip the corner off the bag. And we use a binder clip to secure that, and we just set the ice water right in the top of that.
Should have used something for that. You know what? I think well, you can see it's at the top still. You can still see it's going to the top. I should use more red. Your hole's not. You need to. You put the hole at the top. So just reposition.
Oh, okay.
There you go. Now, with this, we can see the blue really pumping out of there and pushing the red, and the red's up. And so we're getting a current here a little quicker than we normally do even. We're getting a current, and hopefully you're able to see that with this shot. And it kind of happens fast. We kind of had the one way, and it happens so fast. It works, but happens really fast, right? And so we've seen this way done.
Yes.
So we wanted to go ahead and set up and do this, right?
Yeah.
Explain what's going on here.
So in the tank, we have a clear tank, and we just have some room temperature water in that. And Stephen heated up some water. We've put a little bit of food coloring in those just to show this is cold water, this is hot water. And these are the same size beakers. And what they're going to do is they're going to support the tub. So we're going to lift this tub up. And I can already see that this beaker, the hot beaker, is already steaming up the bottom side of it. And that's good. That's what we want to have happen. And so then the students can see, if they're just looking in the tub, what we're each going to do is we're each going to take a dropper of food coloring, and we're just going to put a couple drops. What we're going to do is we're going to before we drop it in. Oops.
Before we drop it in.
Yeah. I'm just going to go clear down to the very bottom.
You gotta say that earlier for me.
Okay. But it doesn't matter. He's doing the hot food coloring, and you can see that heat, even just from the beaker underneath it. This is room temperature water, but that heat even from underneath it is already exciting those food coloring molecules, and they're spreading out a lot quicker. And at the room temperature over the cold beaker, you can see my drops are still fairly intact, and they're going to stay that way. It's going to take them a lot longer because they're not moving as fast.
Yeah, everything I put in there is being pushed up to the top, isn't it? Mm-hmm. Yours is kind of hibernating.
Mm-hmm. And so just again, before you put the food coloring in, you want, as best you can, you want to invert it and try to submerge it as close to the bottom of that tank as possible before you do a drop of the food coloring.
Can I try it again?
Mm-hmm.
You have to tell me this before.
I know. What was I thinking? But I think even when you try that with the hot food coloring, you can see it's spreading out a little, but it just doesn't stay. Now the blue is starting to spread a little more, but it's been there the whole time, and your red is clear up there on the top.
Hey,
so.
The red I just put in is just it immediately expanded. Mm-hmm. See if I can't get us another quick view on this. I don't know if there's too much reflection there or not. But yeah, yours is staying all clumped together.
Yeah.
And mine is definitely spreading out.
Yeah, I think even if you tried to just get a small little dot. So to end, I think it's nice to always assess students with the things that they've learned about, throughout any activity. But I would probably end the States of Matter unit with having the kids come up or develop an infographic. And with the need now, I think, for more and more for virtual options, right, for students to be able to complete a lot of these assignments virtually. I just wanted to show a couple of tools that students might be able to use if they have a device and if they have the internet at home, that they might be able to make their own infographics. Mm-hmm. And so I would tell the students that their infographic would need to include the terms that we covered throughout States of Matter. So certainly they would want to include gas, liquid, solid. But then I'd also want them to include the terms for each of the phase changes. So melting, freezing or solidification, condensation, evaporation, sublimation, and deposition. And I'll have this is on a corresponding slide with the assignment. But then as part of the graphic, I want the students to include arrows as well. And I want each of the arrows to be labeled with the phase changes that would occur between the states of matter. So between solid and liquid, what are the two phase changes? And between liquid and gas, what are the two phase changes? And then I'd also like students to show drawings that represent particles at each of the states. And so I'd probably tell them to include a minimum of 10 particles to show what 10 solid particles would look like, how they would be, maybe how close they would be if it was solid, and then 10 particles that would represent a liquid state of matter, and then 10 particles that would represent a gas. So I just want to show as an example, there's a neat site, it's Bubble Us. And you don't have to, you can actually use it without even creating an account, which I think is pretty cool. It's free to use. You could register with your Gmail account or you could register with Facebook, but I just wanted to show you can go right in with start without signing in, which I thought that was pretty cool. And this is going to bring you up to a new mind map. You just right away get this. Just had to move myself out of the way. So there was a little green arrow. Did you see me click that one?
Yep.
Do I need to go? So when I click that green arrow, it's going to pop up a bubble and I can put whatever I want into it. So let's say I'm going to start my infographic. I'm going to make states of matter, and then I'm going to click off of this. So there's a lot of things I could do with that. But before I start going crazy with arrows, I want to put a couple of bubbles on there. So I have my center one. If I click on it, I can move it around on the board. And then I go back to the green arrow and I'm going to start another one. I'll call it solid. And then I'll make another one and I'll call it liquid. And then I'll make another one and I'll call it gas. Okay. Now I want to arrange these and I can just click and drag and kind of arrange them in like a triangle shape. All right, and these are all my states of matter. And what I'll do now, I'm going to click on liquid, for example, and I'm going to click on arrow as my connecting line. And you'll see that liquid is highlighted in blue. Mm-hmm. And so I have to touch one of these other bubbles to create my arrow. So I'll touch solid, But now I want to make an arrow going from solid back to liquid. So now I'll click on my solid, and I'll hit my arrow. I'll go back to liquid. So now I have a double arrow from solid to liquid, and I'll replicate this for solid to gas, and then for my gas back to solid. Went too fast. There we go. And then between gas and liquid as well. And this way I have arrows for each of the phase changes, each of the 6 phase changes that I'd like my students to show on their infographic. They don't have to use Bubble Us. They could really use anything, but I'm showing this. This is just a neat, free site that students could use to make. What I love about this then is they can create labels for each of their arrows. So if I'm going from a liquid to a solid, what phase change am I looking at? So from a liquid to a solid, if I think about water, if I liquid water to solid water, it's freezing. So what I did is I clicked on there, I set my arrow, I clicked on the actual arrow and it brought up label, and I can just type in freezing. And then if I click off of it, and there you go, and it kind of just puts it right there for me. I go from, click on this arrow from solid to liquid, I type in my label, I know that would be melting, and then click off, and now it's got my label there. I go from gas to a solid. This one always kind of tricks students because these are some of the phase changes that I don't know why they don't get talked about much, but I always like to bring these up. From a gas to a solid, that's called deposition. And students always want to know, well, when do I see deposition? Well, in the winter time, or a lot of times getting into early spring, sometimes you'll wake up in the mornings and there might be a fog delay, or they'll call it a freezing fog. And then when the sun starts coming up, and then all the branches and the just all kinds of things will look real sparkly in the sun. Well, it's because that fog, when it touched that surface, it turned instantly to ice. So as a gas into a solid is called deposition. And then backwards from solid to gas, that's going to be called sublimation. And so kids like to see dry ice. If you can ever get some dry ice, solid carbon dioxide goes straight to gaseous carbon dioxide. It kind of bypasses that liquid state. And so there we go. We have the sublimation there. So once you have this, I was going to show you another tool as well. So you'd fill in your other phase changes. I guess I could go ahead and do that. From liquid to a gas would be evaporation. From gas to a liquid would be condensation. And then let's say, okay, I have this, but I need to put my drawings. Well, I don't know if Bubble Us lets you put drawings or not yet, but I know that Google Jamboard can let you do that. And so one way I would get to that, I use my snip tool on my laptop. So I click on snip and new, and I can cut this out. And then I'm going to copy. And then I'm going to go to Google Jamboard. And so I used Control V, and it just takes it a second. And there's my
the picture, the screen picture you snipped out.
There we go. Thank you. And I'm going to increase this a little bit so I can read it better. Here, I'll just make it larger. But then with Google Jamboard, now I can read everything real well. I know it's states of matter. I've got my 3 states. I've got my phase changes in between them. And now what I can do is I can click on over here. So I see pen, and I get my pen, and I can use my mouse. And I don't have a fancy writing tool or anything, but you can do this easy enough with your mouse. And I want to show my 10 particles. Actually, I'll do solid. So there's 1. I know for a solid, the particles are going to be a lot closer. And they look a little more like squiggles than particles, but there's 5. And I know I'm just making 10 of them that are going to be really close together. And now I've got my drawing part of that as well. So kids could make their own infographic and show, just to document, the things that they learned with the states of matter. We sort of got this idea because we use the infographic a lot when we're teaching states of matter in the classroom. This is one that we found that we'll also share this link as well. But this is a little bit fancier. It definitely has the particles. There's gases, there's liquids. There's your solid. It's definitely more structured, and it does have the arrows. So this is an example of one we've used, but I might not give that to the students. I might have, or show students what something like this. I might have them create their own before we talk about this, or you could even share this with them after they've turned it in, and that could be something they could evaluate their own poster and see. So.
Cool. Cool beans. That looks doable.